Oh, we'll just wait like two or three more minutes for everyone to come. Hello, guys. I think we should get started now. So all of you guys should have, if you guys haven't, could you quickly do this right now? Go to our GitHub and so do two things. One, upload the, or actually, no, wait. Yeah, so just download the week 3 pre-processing notebook and have that code open in Colab, please. And then I think we'll get started. So today's plan, we're actually just going to start coding today. And we're going to go over two things. We're going to go over linear regression, just really basic linear regression project. And then we're going to do a really basic machine learning neural network project. So I think for Raj, we'll go ahead and get started. Raj, you're muted.
Can you guys hear me now?
Yeah.
Okay. So if you guys remember, last week I showed you a very general and basic linear regression project. Today we're actually going to make that. You're going to make it yourselves. So could everyone go to Google Colab right now? So that's just colab.research.google.com. And from there, click New Notebook just to open something up. And you guys can call this whatever you want. I'm just going to call it class and reg project. Okay. Is everyone there? Okay. If you guys are there, okay. I'm just going to get started. So I'm assuming all of you have a base knowledge in Python, and the first step we're going to do is import pandas. And oh, let me back up for a second. Sorry. So just to remind you, the entire point of our project today is to predict the salary of an employee based on how many years of experience that we have. And usually this is a linear correlation. So if you have more years of experience, obviously you'll have a higher salary. And we're just going to use a machine learning project to kind of simulate that. And so the first step we're going to do is import pandas, which is a basic Python library, a basic Python library for working with your data. So import pandas as PD. And our next step will actually be to get the data. And to get the data, you have a lot of options to do this. You can either upload it directly through Colab or you can upload it through your Google Drive. And what I'm going to do is I'm just going to get it directly from the GitHub. So I'm assuming all of you were able to get the salary data.csv into your GitHub repo. That was one of the assignments we had for you before today. And so you're going to click on that right here. And then it should look something like this, right? But you're not actually going to use this. You're going to go to and click this button, raw, okay? And raw will just give you what the basic outline of the CSV will look like. It doesn't have any sort of structure to it. It doesn't have any extra outline to it. It's just the raw data. And you're going to copy the link up here like I'm doing, okay?
Excuse me?
Yeah, what's up?
My Zoom meeting wasn't working for some reason and I just got here. Do you mind briefly going over what you said?
Yeah, so this week, we're going to start coding. And the first project we're doing that I'm demonstrating right now is a linear regression project. And it's the same one I was demonstrating last week, but you guys are actually going to code it yourselves now. And what we're going to do is we're going to predict the salary of an employee based on how many years of experience they have. So if you have more years of experience, you have a higher salary, and we're just going to simulate that. And so for anyone else who got here late, what you're going to do is you're going to go to Colab and create a new notebook. And right now, just import pandas, the Python library. And so we have the raw file now, and we're just going to copy that link right here. And next, what we're going to do is we're going to get our data set by just initializing a variable that's completely with our data set. So data set equals pd.read_csv. And then in here, in these brackets, you will just copy your link there. So now we have all.
Got to that link.
What was that?
I don't get how you got to that link.
Viraj, just give the link in the Zoom chat.
I don't have the chat open. Could you give it?
Yeah, sure, I'll get it.
Yeah, and
I'll give you guys the link.
Make sure it's the raw file. Only the raw file.
Yeah, I got you.
Okay. I guess you guys will get to that. But our next step will be initializing our x and y variables, and our x will represent how many years of experience you have, which is our independent variable, and our y will represent the salary, which is our dependent variable. And we're just going to take this directly from our data set. So x equals dataset.iloc, and then, my bad.
Wait,
and
is there
then
not a Zoom chat? Does anyone see the Zoom chat? I can't. What?
Yeah, my Zoom chat, it's not there. It's like non-existent.
Okay, well, why don't you go? If I put in a Slack, will you guys be able to access it? I'll put it in a Slack, but I don't really have a better way to do it then, because there is no Zoom chat for some reason.
Okay. I'm not sure how much experience you guys have with Colab. So if you have a different way to upload the file, then I guess you could try that. But this should work. So right here.
I don't have this. I don't have this in GitHub. I can't access the GitHub, your GitHub repository that you shared. I can't find that in GitHub.
Just use the link that I put in the Slack. It'll work.
Yeah.
Can you zoom
join.
in to your code?
What was that?
Can you zoom into your code?
Sure. Can you see it better now?
Thank you. Yeah.
Okay, so what we're doing here is using.
I have a
was that?
question. So
Yeah.
I made the collaboratory, but
Mhm.
I don't. How do you upload it to GitHub again?
Just do it later. Don't worry about it now.
Don't worry about that. I'll show you later. Anyway, so using the variable, the command iloc, we're going to create a 2D array of the years of experience you have. I think you guys know what that means because you should have taken the Python class before coming here. And we're going to do the same thing with the y variable. So dataset.iloc, and then 1, which should give you the values of the salary data. So now we've initialized our variables that have our data. And from there, we're going to create another code cell. And right here, we're going to split our data set. So we have all our data in this file. And we just want to put it into a train set and a test set. So what we're going to use for that is
How do you split it? How do you put that?
I'm going to show you that right now. I'm going to show you. So what we're going to do is we're going to use the scikit-learn library, which is basically a machine learning library. So we're going to say from scikit-learn.model_selection, we're going to import the train test split. And we're going to have 4 different sections. We're going to have xtrain and xtest, and then we're going to have ytrain and ytest. And then we're going to split it by with this command, test train split, and then we're going to have x, y, 1 second. And then for our test size, this is how we split our data set. We're going to have test_size equals 1/3. And what that does is it allows us to split our data set into 1/3 of it being for the test, for how we can test that our code is working, that our machine learning model is working. And the rest of it will be for train, which is to actually train our data set. And random state. Yeah, what's up?
Do we need to copy down all this code right now?
Yeah,
You should. Definitely. So open up a Google Collaboratory and be sure to do that. And with this, and just literally with one line, oh, I made a typo here. With one line, we're able to essentially split our data set into a test section and a split section.
Can you please slow down?
Yeah, sure. Does anyone need me to go over any part of that again?
Can you explain what each line is doing?
Okay, sure. So import pandas. So I'm assuming you guys know what pandas is because you learned that in the Python class, but just to go over it, it's a way for you to interact with your data, with your CSV, right? And right here with dataset equals pd.read_CSV, we're getting the data that we want and we're putting it into a variable. And using this variable dataset, we're able to access our data that we want to use to train and test our model, right? And then with our next line, we're going to take the part of the data set that has all our years of experience, and we're going to put that into one variable called x. And using x, we'll be able to go back to all the years of experience that our data provided. And we do the same thing with y, so but with your salary. So all the salary data that's in your data set, we're going to put that into the variable y. Does all of that make sense so far?
Sorry, what is the difference between X and Y again?
So if you look in our, 1 second. If you look in our data set, my bad.
X and Y are your variables for your graph, X axis and Y axis.
Yeah, so you have X as your years of experience, so this entire column, and your Y is your salary, which is this entire column. And then from there.
Right. But how does the code know which is X, which is Y?
Because
you say X equals.
Yeah. This dataset.iloc, that's the part of the code that tells you that you're talking about the years of experience, and you're just saying that it is X by making them equal.
Wait, how did you get the link, the raw GitHub?
I put it in the Slack. Please check the Slack.
Just check the Slack and copy.
Because there's no Zoom chat today. I don't know why.
Mm-hmm. Anyway, so I'm assuming that makes sense. And then from there, so we have this entire data set, right? But
I have a quick
now
question.
Oh my god.
Yeah, what's up?
Will this video be posted afterwards? Like,
yeah, it will.
Okay, thank you.
And I'm gonna post a notebook with all the code.
It's already there. You can look. You can follow along there if you want as well.
Yeah. So from there, we're going to split the data set.
All of this code in?
It's in the
Uh,
GitHub. We've said this many times.
It's in linear model project under lesson materials. Anyway, from there, we're going to split our data set into a test section, into a train section and a test section. And using this 1/3, we know it's going to be, the 2/3 of it is going to be for our training data, and the other 1/3 is going to be for our testing data. Everyone got that? Okay, cool. So from here, we have everything we need. We have the data, and we have our algorithm using the scikit-learn. So to get our actual algorithm, we're going to say from scikit-learn, learn.linear model, import linear regression. Okay? And this allows us to use all the capabilities of linear regression from scikit, and this is much easier just initializing it from scikit than doing the entire mathematical thing we went over last time. So we're going to put all the whole linear regression thing into a variable which allows us to access it. So regressor equals linear regression. And so this function just has all the linear regression stuff, and we're putting it into regressor, just like we did with the data and X and Y. And then, so using this algorithm, we're going to map it to our training data. So all the training data we have, we're going to do the whole mathematical concept thing we did last time with just one line of code. So regressor.fit, and then xtrain, and then, my bad, xtrain, and then ytrain. And so all the X and Y training data that we have, that we initialized over here with xtrain and ytrain, we're just fitting that data to the regressor model in the way we showed last time. Everyone got that? This is the part where we actually like train our model, just this one line of code. Okay, so now we have the entire model, right? We have the entire model trained, and now we want to see how well it does. So we do that saying using the y predict variable. So we're going to say y predict, or we're just going to say pred is regressor.predict, and then we're going to use our x test variable. So using the testing data from the independent variable that we haven't used previously, that's still there, that 1/3, we're going to predict how well the our algorithm can map. And then right now, obviously, we haven't been able to see anything, right? So we're going to be able to see how all this is working out with another Python class called matplot. And matplot is just a way for us to graph how well all this is doing. So the first thing we're going to do is graph how well our model will fit with the training data, okay? So we're going to import matplotlib.pyplot as PLT. And from there, we're going to scatter all the training data. So all these random points that we came up with, we're going to put that into our graph. So we're just going to say plt.scatter, and then xtrain, ytrain, and then we're just going to give it a color for fun, which is red. And then now we're going to actually plot the training data, right? So plt.plot, and then xtrain, and then we're going to predict, regressor.predict xtrain, and then we're going to give that a color of blue. So this is just kind of our line. You guys understand? We're just predicting it using the line we came up with. And then now we're just going to give it normal characteristics of a graph. So plt.title, so salary vs experience, okay? And then now label, experience, and then last we'll just have a y label, salary. And just so we can see this model ourselves, we do plt.show. And now that we're actually able to see everything, let's try running this code and make sure there are no errors, okay? So everyone who's following along, just highlight, oh, actually you don't have to highlight all of it. Just go up here to runtime and click run all, okay? So run all.
Can I request, I still don't have that CSV file link.
It's in the
Can
Slack.
you
It's in the
email it
Slack.
out? There's no chat here.
It's in the Slack. It's in the Slack.
Wait, what?
I said it
So
like
here
4
we have an
times.
error. I must have copied something wrong. Let me see.
For
Oh,
the when you labeled the color blue, I don't think you put the single quotes.
Yeah,
for
you're
that.
right. So let's just run it again. Yeah, thank you for catching that.
Good
So run
catch.
all.
Can you give us a little time to copy this down?
Yeah, sure. So you guys, are there any questions you have? Because as you can see, we now came up with the graph, and the blue line is how we predicted our actual model, and the little red dots are the actual characteristics that you see over here. So each of these points that are here, that's a red dot, and the blue line is what we predicted. Do you guys understand?
Sort of go over it like
Wait,
the
when I
entire
run
code
my
one more
code,
time, what
I
it
get-
means and everything.
Wait, one at a time. Yeah, sure. I'll go over it
When
again.
I
But
run my code, I'm saying at dataset equals pd.read CSV link. It says it's an invalid syntax.
did you copy this down exactly?
I copied it from the repository.
Yeah, you have to go.
I ran
when
the
you're
code that you gave from the repository.
the linear progression model.
Yeah, it's called linear
Right.
regression.ipynb.
Yeah, right. That one I didn't update that one yet, but at that point I was using an actual file. Now I'm just using a
I
link.
typed instead of something.csv, I copy and pasted the link there also.
Did you put
The link
quotes
that
around
I
it?
provided.
Yeah, the link that you provided.
Did you put quotes around it?
Oh.
I need. Okay, cool. Okay, so let me just go over this like one more time really quickly. So we import pandas.
How do you run this again?
Oh, go up here to runtime and click run all. So we have a data set. So first we import pandas line 1. Then we initialize a variable data set with all our information from the data set, all of this code, all of this data. And then from there, we're going to initialize a variable x that has all the data from this column, years of experience. And then we're going to do the same thing with the variable y, which is all our salary data. So right now we're just doing all data stuff. We're just making sure our code can recognize that we have a data that we want, right? Then from there.
Sorry, 1 second. On those two lines, X and Y, can you explain the colons? How does the code know? What is the significance of -1 and 1, for example?
So that just has to deal with creating a 2D array. So I'm not sure if you guys learned about that in the Python class, but basically a 2D array is something that looks like this. So let's just print X and run it. Wait, how bad? So this is what a 2D array looks like, right? And so to do that, -1, it just refers to this leftmost column, which is years of experience, and just regular one will refer to the other column. And so we just want to create a 2D array that will look like that. Okay, so moving on, we're just splitting the data set into 2 sections, which are our train section and our test section, which we talked about extensively last week. Then from there, we're actually mapping our training data to our model and kind of just allowing and doing the whole mathematical thing we talked about last week, which is where we just provide data, we try and get our line as close to it as possible, right? So this is where we actually train our model. Then we want to test how well our model is working. How well can our model actually test how well can our model predict data that it hasn't seen before, right? So we do that with the predict function. And then from there, we will just plot this data so we can see it. So all of this is just so for our visual ability to see. And we just create a graph.
Wait,
for it.
can you go back to how you made the chart, like how well the computer knows that stuff?
Which chart?
Like how well the computer knows the two sets of data or something like that.
I'm sorry, do you mean like the data set or the linear regression or what?
No, linear regression.
Yeah, sure. So the important thing about scikit-learn, so this part, right? Are you talking about this?
Mm-hmm. Yeah.
Okay. So the important thing about scikit-learn is that you don't have to do all the mathematical stuff we talked about last week. You guys remember how we had to talk about calculus and all of that? You don't have to do all that. So if you just import scikit-learn and the linear regression part, the computer will automatically have all of that available to it. And so if we just say regressor.fit, it will be able to automatically pair all these little points with the line. So we start off with a line and we just want to get the line as close as possible to all these little points. And we do that using this line called regressor.fit. So I'm just going to move on because we're running kind of short on time and we want to get to the neural network stuff. So we want to do the same.
All right, are you done, Raj?
I just have one more section.
Okay.
He's not
I
done
also
yet.
have a question. Where is the linear regression? I mean the linear model thing on the GitHub?
What? Oh, go to lesson materials right here.
Oh,
Anyway, so we're just going to do the same thing right here with our predicting area. So we see how with our prediction data. So we just see how well the same line will map to data it hasn't seen before. So we do that saying import matplotlib.pyplot right there. And so the first thing we'll do is exactly what we did last time, plt.scatter and then x test, y test. And then we're going to say the color is red again. And then we're just going to plot, plt.plot, xtrain regressor.predict. This should be x-test, sorry. Oh no, it is xtrain because we're taking the same line that we did before. And so from here, I'm just going to copy this code that's right here because I don't really want to type it out again. And so this should ideally give us the plot again. So we're just going to run all to see what that looks like. And we can see we came up with the graph. So the lines from these two are literally the same line, right? Because it's the line based on our training data. But you can see here, we changed the data just to see how well it maps. And we can see it's really close to all the data points, right? It's relatively in the same position as all of them. And using that, using just like these few cells that we've created and under 50 lines of data, we're able to create a simple machine learning model. So that was the entire linear regression thing. Ayaan, do you want to go to a neural network now?
Yeah. So let me go ahead and screen share then.
I have a question.
Yeah.
Can you put all that code in the Slack?
It's on the
It's already
GitHub.
in GitHub.
Oh, okay.
So just go to GitHub right now.
All right. So let me go ahead and screen share. Okay. Screen share. Okay. So I think you guys can see this, right? Excellent. So today we're going to build our first basic model, machine learning model. And so we're going to go over concepts such as data pre-processing, which you do with Faraj, very similar stuff. That uses NumPy and Pandas, which are two libraries that you have to get very used to. We're going to build a data set because we don't have a real data set. We're just going to build one really fast. And for the building the data set, you guys should have copied the code from the GitHub. If you haven't done that, please do it really quickly. Just go to the week 3 pre-processing notebook and copy all that code.
I have a question.
Yeah.
when I'm on like the shelter in place doc, and then when I click on the GitHub, I mean the Slack link, it says link is no longer active.
I don't know about that. I think you're gonna have to ask Shivam or something. But what do you need? I can like. Okay. Anyways, so then we're gonna create labels for our data set, and labels are basically for each piece of data. Like we went over this last time, but for each piece of data, you have to have a label attached to it so your model knows what it is. Then we're gonna build a simple sequential model that just has 3 layers, and we're gonna use Keras and TensorFlow. One sec. And then we're gonna use, we're gonna train the model, we're gonna make predictions, and then we're gonna create a confusion matrix, which basically shows you the basic metrics of your model. All right. So let's go over to Colab, and we have all of this. Let's just go over our project real quick. You're supposed to have this downloaded, but I hope you guys do. Anyway, so basically we have 2 arrays for our labels, or sorry, for our train labels and then train samples. We're just going to import these 3, which you should already have imported. And then we have, this is how we're just creating our data set. You don't have to worry about this, but that's just our data set. And then here we are creating our labels by using numpy.array, and we create an array out of the labels. So, one second, sorry. Okay, so let's go ahead and get started with building our basic model. So first, what we're gonna have to do is we're gonna have to add a new cell, right? And so first, we're gonna have to create to scale our model or scale our data. And what that means is we have to make our data into a format which our neural network can process. And this is a bit confusing, so don't really worry about how it works, but just understand that it's like resizing and things like that. So first, we're gonna create our scalar, which is gonna be min max scalar, and then feature. Oh, whoops, I'm not connected. One sec. Okay. Make sure you're connected to your something just so you get your autofill. And then we'll do, the range is 0 to 1. And then we'll do scaled train samples is equal to scalar dot fit transform. And that basically converts our data into a readable format. Train samples dot reshape, and then it's going to be -1 to 1. And that's just making it into a format that our data can read. So let's go ahead and quickly run all the cells just so you guys can see how that looks. So, and that ran, right? So now let's go make another cell. And now let's just look at how our data looks. So if we just copy this piece of code, it's going to be for I and scaled train samples. If we just do this, we see all of our scaled. So now instead of being, so up here we had, these were our numbers, right? These were our data points, but now we have them in the format of decimals, and they're arrays now. Does everyone understand this? Okay, so let's keep moving. So now we're gonna build our actual sequential model, and yeah, nice. But so basically we're gonna get a bunch of imports. I'm just gonna copy paste them, but I'll give you guys a second to write them, and I'll explain them while you guys copy them. Keras is our basic, it's the library for all neural networks. There's pretty much 2 libraries that you'll ever use, Keras and PyTorch, but Keras is like the industry standard. It's a lot better, or it's more easier to understand. So you guys will be using this, and then we're going to import just the backend stuff. Then we're going to import these. This is our model. We're going to use a sequential model, which we went over last class. Then we're going to import the activation functions. We're going to import the actual dense layers. We're going to import our optimizer, which is Atom. And we're going to import our loss function, which is categorical cross entropy. That's just a different loss function. Don't really worry about how it works. But I can give you guys a quick visual of how that looks. So this is what our model looks like. We have This is our activation function, which is ReLU. This is what our model is going to look like. And then this is what this is what it's going to look like, and this is how we're going to code it. So if we just copy paste this code, if we go ahead and run this, it'll work, right? Because it's using all your TensorFlow stuff. And then we're going to create our model, and is hopefully that you're following along. So basically we have our model, right? And then we're going to initialize it as sequential, and then we're going to put parentheses, right? And then in the brackets, we're going to create our layers. So we're creating 3 layers. Our input layer is a dense layer with 16 nodes, which means it's a 4x4. Input shape of 1, and then activation is the ReLU activation function. Then we have our dense layer, which is 16. There's 32, which has 32 nodes in the middle, and it is the ReLU activation function. And lastly, we have the 2 outputs because it's just binary classification. We're either classifying someone as, let me just quickly explain our problem. I didn't explain it that well, but our experimental data. So basically, an experimental drug was tested on individuals from 13 to 100, and the trial had 2,100 participants, and half of them were 65 years old, and half of them were below, and half of them were above 65. And 95% of patients above 65 experienced side effects, and if they were under 65, they experienced no side effects. So our goal is to get someone's age and determine if they are going to see side effects. So the only outputs that you'll get are if they have side effects or they don't have side effects.
Can you slow down a little bit?
Sure. If you guys have any questions, just ask now. The reason I didn't go over the data set is because I asked.
You're going a bit fast.
Okay, thank you, Sean. But yeah. What's the question?
How do you download the file from GitHub?
You use the Open in Colab extension, and that will open it in Colab for you, and then you can make a copy of it just by doing file.
What is TensorFlow?
TensorFlow. Okay, so Keras is our what is it? Keras is our library that we're using. It's like scikit-learn that Viraj was talking about, but it's just another version, and it's for neural networks specifically. And TensorFlow is just like the higher level. Like Keras is part of TensorFlow.
Because I knew that TensorFlow was for object recognition and stuff.
Yeah, so that's like machine learning, right? TensorFlow is used for object recognition. That's just one part of it. Maybe you got that from robotics. I'm not exactly sure, but yeah, Keras is specifically for building neural networks.
Okay, thanks.
Yeah. Okay, so I guess here is our basic model. And does everyone understand what this looks like? Right, I think I showed the picture, but okay, let's keep going then. All right, so after we do this, we can just do model.summary, right? So that'll just show us what our model looks like. And so this is a basic example of a basic just description of our model, right?
Hey, sorry, really quick to stop you. Would you mind going up a little bit to where you had like scalar is equal to min max scalar?
Oh yeah, sure, no problem.
Thank
right
you
here.
so much.
So yeah, so this is just scaling our data into a readable format for the model, because the model can't just take in like a number, any number. It needs to be specifically between 0 and 1, and it needs to be in the form of an array. So that's why we're scaling this. It's not that important to understand how it works. Just you have to understand that it does work, and that's what it does.
Would you mind increasing the font size a bit?
Oh yeah, sure. Sorry.
Thank you.
Is this better?
Yes, thank you.
No problem.
So I'm getting an error on the scalar cell that says min max scalar object has no attribute. What does that mean?
Did you import it? I think that's probably the problem. You're supposed to you're supposed to import it up here.
Okay.
And the reason I skipped over this is because I asked like 5 times in the Slack before the class. I just asked people to do it so we didn't have to go over it, because it does take a little bit to generate the data set. But yeah. And I guess it turns out a lot of you didn't copy the code, which is not that big of a deal. What you can do, you can follow along what we're doing now, code it yourself, and then if you want to try it on your own, you can just copy the stuff from the beginning, and then it should run just fine. But let's just go back. It is, yeah, it's been on GitHub for a while. So let me explain what our model looks like. It has, again, 3 layers, right? A dense layer 2, and dense layer 3. Our output for these ones are none, but the shape is just a 2. So 16, 32, 2. And then we have the parameters. Parameters are basically how many different weights we have. And if you guys were here last week, you remember that a weight is basically the connection between each node in a neural network. And there's a lot of weights that we have to change. So we can see there's a total of 642 weights that we have to adjust. And we're not doing that by hand, don't worry, obviously. That's what our model does. But we have to adjust those through the training process. So that's what we're doing. And the non-trainable parameters means that there's none that aren't going to, all of them will be changed. And 642 of them will be adjusted throughout the training process. And our goal is to basically fit this model to our new data set. So let's go ahead and create our optimizer, and just like the basic stuff. So right here we have model.compile, and if you guys remember what the optimizer does, the optimizer basically does all the math for you. It'll do all the gradient, all the calculus in the background to adjust your model for you, and you don't have to worry about it. So the optimizer that we will use is called Atom. And so we're giving it a learning rate. LR means learning rate. And if you guys remember, the learning rate is basically just, it's just how fast we want our model to learn. And usually it's between 0.1 and 0.0001. And here we're just using 3 zeros. And then our loss function is called sparse categorical cross entropy, which is just a type of loss function. Let me go ahead and show you guys what that looks like. So right here, this is what the Atom optimizer does. You don't have to really worry about what it does, but you can see that it's a lot better than other optimizers. And then this is our loss function. Basically, it uses a log, which is like logarithm, but you don't have to really understand how that works. Just understand that basically your loss is going to decrease if the prediction was closer to the actual target, and it'll be higher if it was far away from the actual target. And it's based on confidence, which means that you're going to get penalized for a bad prediction and you're going to get rewarded for a good prediction. So let's go ahead and move on. I think, and then metrics just mean, this just shows accuracy. It's just going to show us the accuracies of the model. So does everyone understand like what the optimizer does? We went over it last time, but I think we got a good refresher of what it does. So now let's just go over how we're going to train our model. So basically, the next cell right here, I'll copy it into our collab, but basically what we do is we're going to do .fit, and we're going to pass in a few different different parameters for our function. So scaled train samples right here is just the data that we will train our model on, and they have been scaled so we can use our model, and that's what we did earlier with the min-max scaler. Then we have the train labels are just the labels, and they're all in the correct order for our train data, and they align with each piece of data. So like we'll say one is the age of 65, and the other one is the actual, did they see adverse side effects? Yes or no, which is 1 and 0. 1 means yes and 0 means no. And then the validation split is how much of our data we want to split off for validation. As you can see right here, remember we have a big data set and we want to split off a little bit of it for validation. And this time we're just going to use 10%. That's why we're using 0.1. And the batch size is how much data we want to input at once. And we're just going to use 10 pieces of data right now, which is just a good number to use. Sometimes you'll use 16, sometimes you'll use 64 based on the size of your data set. And then we're going to train for 20 epochs, and that just means 20 iterations of all of the data, which means that once we give the model all of our data, that's just 1 epoch, and then we're going to do it 20 different times. So it sees the data over and over again and learns from it. So in the same time, like it will take more than one time for you guys to learn this material, right? We need to give our data to the model multiple times so it can learn multiple times. And then we're shuffling the data and rearranging it to improve accuracy, but you don't have to really worry about that. And lastly, verbose means how much the model is telling us, and we'll just use 1 over here. We'll just use, and 2, we'll just use 2 to show us like a lot of the updates during the training. So if you go ahead and copy our model or our training function and we run it, that's just going to do all the training. And we can see that it's training now. You're never going to see a model that trains this fast in real life. It's usually not going to be when you do real models. But since our data set is really small, we have it's going really fast. So basically,
At the
we
end
trained.
of the class, can you go over everything that we learned today and did today?
Yeah, I will do that. So basically, but you should try to follow along. I mean, I think the main reason a lot of you guys are getting a little behind is because you guys didn't have all this code copied, which we should have done. But I think you can still understand what our model is doing. So basically, we trained, right? We trained on 20 epochs, and each one of these is each epoch. And as we can see is that it's saying 0-second time. And then what we can see is the accuracy to start with is really bad. It's just 57%. But then as each epoch, our weights are being updated, and we can see that the accuracy is slowly increasing, usually by 4% each time. Like up here, we're seeing an increase. We're seeing here an increase about 9%, 4%, 4%, about 1%, and eventually it gets up really high, and it gets to about 91.8%, which is pretty good for a machine learning model. That means that means it's getting 91% of the data that it's being trained on, it's guessing it correctly. And then on the validation data set, which is what we're trying to see how our model how it predicts data that it hasn't seen before, we can see that it's getting very high at a 98%. And again, we have 210 data samples that we're validating our data set on, or our model on, and we have this many samples to train on. Yeah, so basically, and again, this accuracy is for the accuracy of the data that's being trained on, and this is the validation accuracy.
If you guys remember from linear regression where we split it into a train and a test, this is basically the same thing.
Anyways, so next we can go over to, let me get my, so if we go over back to the Jupyter notebook, this is what it looks like. And the easiest way to save our model once we're done training, so what we have here is we have this model.save, right? And it's just, we're going to give it a name and we're going to save it as an H5 file. H5 is just a type, it's just a data type to save our model as. It doesn't really matter. That's not a big deal understanding how it works. It's just, you should save your models as H5s. There are a couple other options, but H5s are usually the easiest ones to save it as. So if we run this, and so let's say we make a new cell, and then we run it, you can see that our model has now saved over here. And what you can do is you can download the file and then put it in your GitHub if you want. So let's keep moving. And basically this is like a basic idea of how like it looks. But what we can do is we can just load it again. So like once you save your data, once you save your model, you can open it in another file, right? So let's say this was a different file, and let's say like I didn't run any of this code before, but let's say I had the model, right? Oh, whoops, I downloaded it by accident. But anyways, right, we have this. So what we can do is we can open it again. So we have to use keras.models, and we have to do import load model. And we just do new model is equal to load model, blah, 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 right? And then once we do this, we see that we've updated our new model. So if we do model.summary, right, and this summary just shows you what your model looks like, that's what it looks like, right? But then if we do new model, we can see that it's the exact same thing. It's the exact same model, same architecture, same layers, same amount of parameters, same everything. It's the exact same thing. So that's important. Let's say you train your model in one file, and then you want to make predictions within another file. That's why you would have two different files. That's why you would save it and you would load it later. But let's keep going. Right, and again, you can see that it's very similar. So why don't we go ahead and make predictions on this data? So here's how you would make predictions. So you just do predictions. Sorry, let me just copy it. So here's the line to make predictions. And basically, let me explain what each part does. So predictions, that's just like the variable for predictions. And then we do model, which is our model. We can even use a new model if we want. It's the exact same thing. It'll work just the same. We'll do model, and then we'll do dot predict. And predict, basically, we're giving it. And the reason, here's what it means. So basically, now that our model is trained, we'll give it some data. And with that data, it'll make a prediction on whether it thinks that it'll see adverse drug effects or not. And again, that's the point of our model. You guys are supposed to go over the data set before. But again, it's basically you give them someone's age, and then you predict whether or not they're going to see side effects for the certain medicine. So again, we're going to pass in our test samples, which we created earlier over. Oh, okay, yeah, hold up. I didn't do it. I forgot to. Let me add in a cell right here. I have to copy this. So we're gonna create test samples now. So first what we have to do is here, and then what we'll do is we'll just create the test samples. These are random test samples that we're gonna make. And then so now again, a batch size, we're just passing 10 at a time. We're just giving it the sample, and then we're giving it verbose, which is 0, because we don't want to see updates. And then once we do that, whoops, I didn't run this. Did I forget something? Oh, right here, I forgot to do this. Yeah, I forgot to scale them. That's important. So once you create the data set, you have to create test samples, and you have to scale them. Again, you have to scale them so that our model can comprehend them. So now when we run this, we're gonna get predictions, and then those are saved. And then after that, what we can do is we can look at our predictions. So we do this. And now let's analyze what these really mean. These just look like a lot of numbers, but let's explain them. So basically here, each input right here, each array is basically your predictions for each piece of data that you're inputting. So let's just put a line of code right here, and we can just look at if we just print the scaled test samples, right? We can see that these are ages, right? So someone is 100 years old right here. This is 25 years old, blah, 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 right? So the first one is, if you scroll up, the first one is 47 years old. So with that, we're seeing that a 47-year-old has a 65% chance of not seeing any harms, right? They're not going to see a bad drug effect. And basically here is our first label, which is 0, the label 0, which again, the label 0 corresponds to not seeing any effects. And then we have the other label, which is the label 1, which is the effects that you'll see. So here we see that it's a 65% chance that the person saw the drug, didn't see harms, but a 34% chance that they might see harms. So it gives probabilities. And the next person, it's really high that they will see harms. It's almost a 94% chance that they will see harms, which means that most likely they're going to see some sort of effects from this medicine. For the next person, 75% chance they don't see it, and so on, right? And these add up to 100%, and it just basically splits the probability of seeing each one. And that's what these mean. So based on this, once we get these predictions, we can round them, right? So now we can create something really useful out of these, right? So if we just round these predictions, right, it's the exact same thing, and then we're just going to do, the only difference is you do predict classes instead of just predict. These predict classes will do the work for you, and it'll do the work, it'll find which is higher probability and just output that. So if we do this, and then we just do, it should be the same code, same line right here, same for loop. Rounded predictions. We see that we're just getting a bunch of zeros and ones, right? And again, 1 means a positive label, which means that they will see a harm, and 0 means they won't see a harm. So for the first person, it's a 0. And if we go back up here, we see that the first prediction, where is it? Right here. The first prediction, we see that it's a 65% chance that they won't see a harm. And that's why we see that the label is 0, right? Which it's higher probability that they won't see a harm. And that's when we round it, we're just gonna say that they won't see a problem. But if you want to actually apply this and give a real prediction to somebody else, let's say I was your doctor, what I would do is I would, if I was a doctor and I used this model, I would tell my patient that, hey, there's a 65% chance that you will see no harms, but there is a 35% chance that you will see a harm. So while it does say 0, it's important to notify that it's important to know that that the probabilities, because the probabilities do still matter, but this is just rounding them, because it's just saying that if it's above 50, it'll round up to 1, and if it's below 50, it'll round up to 0, round down to 0. That's like basic rounding. I'm sure you guys know about that. And then lastly, with this, we can create a confusion matrix. And let me actually create it for you guys, and then I'll explain what it means. So basically, you guys don't have to worry about, don't worry about coding this yourself, but I'll just explain what this concept is. Whoops. And yeah, don't really, it's not a big deal of understanding how this works, but, how to code it, because you guys can always code it later and you guys can see the code. But since we are running out of time, I'd like to explain what it does. And so right here, a confusion matrix is basically telling us, so basically let's examine this, right? So we see that there's true labels and predicted labels, right? And so that means, let's say for one data, right? So this person, let's say I was 70 years old, and then I did see a drug effect. So that means the label is going to be 1, right? And let's say I input it through my model. If I input it through my model and I also get a 1, then it's going to go over here in this confusion matrix, right? And it's going to show you that it was a true positive. And what that means is that you have the true with true or false, right? Which is true just means like, did it, what, like in the actual data set, right? Was the real label like a true label, which means that they did see harms, or was it negative, which means that they didn't see harms, right? And then we're plotting it against the side effects that they had that they saw, right? So we're seeing that no side effects and no side effects, they match up to show that it's a true positive. And then there's true negatives. True means that, yes, it was true. The real label was negative, and they also guessed negative, which means that it's a true negative, right? And then the other two are false positives and false negatives. False positive means that in reality, they didn't see any harms, but we predicted that they did see harms, which isn't good, but it's not that bad, right? In like a real world situation. For the other one, we'll see that a false negative, which is pretty bad. So what that would mean is that in reality, they were, in reality, they were positive, but positive for the negative reaction, but our model predicted that it wasn't, and that's bad. And the reason that was bad, let's think of like the coronavirus, right? Let's say that I had coronavirus and then I got a test, and then based on that test, the test said I was negative. That's not good, because now I can go out, I think that I don't have it, so when I go out, I can give it to other people, which is obviously bad, right? And let's say like the test comes in negative, and I really do have it, I can get sick, and I might be in the hospital later, right? And I won't be able to treat it fast. So that's why false negatives are the worst, but you always want true positives and true negatives. And at the end of the day, we can see that our model is doing very well. We see that it's the majority of them, 190 were true positives, and 200 were true negatives, and only 9 and 20 were not correct predictions, which means that our model is doing very well. So I think that's just the basic model. I think we should just go over everything again, because not everyone, nobody, I don't think anyone actually did it. I don't think anyone copied the code from the GitHub, which we asked, but let's just go over. Basically, this is the data. An experimental drug was tested on individuals from age 13 to 100. And then we have 2,100 participants, which means that we have 2,100 samples. And half were under 65, half were over, which means that we have a very balanced data set. And then 95% of the patients above 65 saw side effects, and 95% below 65 didn't see any side effects. And right here, this is just the code for creating the data set. It's not a big deal. So then let's just go through what we need to do to create our model. First, we have to create labels, right? And we just input 0 and 1 for labels, right? So we have to first convert them to NumPy arrays, right? And NumPy arrays are 2D arrays, and NumPy arrays are needed for machine learning models. And all you have to do is just do numpy.array and then put in your Python array into the NumPy array. Then this is what we went over at the beginning. We scaling. Scaling just means that it's basically converting your data into a way for your model to understand. And think about it like, let's say, just think about it like you're talking to your friend who doesn't speak English. You have to use a translator to convert what you're saying into another language so that they can understand. It's the same concept. You have to convert your numbers from real numbers into arrays so your model can comprehend it. And we just use scikit-learn to do that. And then based on that, we get scaled models. And then if we go over the model, we have to import a bunch of these things from Keras. Keras is our library that we use to build models. It's very good. Most people use it for building models. And this is our model. This is like the core of our project. It's really simple here, but like obviously you can see a lot bigger neural networks. But this is a very just simple neural network with just 3 layers: an input layer, a hidden layer, and an output layer. We see that there. So if we go to the summary, we can see that there's 3 layers. They're all dense layers, and dense again. We went over this last class. Hopefully you guys remember. It means that you have to connect each part. And then with that, we have an input shape of 16, which means that we have a 4x4 Python array or a NumPy array. And then we have the parameters. All these parameters are weights within our model. And a weight, again, is just a connection between each node in each layer. And we have to adjust 642 of them. And that's what our optimizer does. So Atom which we give a learning rate of like pretty low, it's going to use the loss function and calculate the loss. And again, the loss is basically the difference between the predicted label and the actual label that we saw. So again, let's say the real label for a certain data set was 1, and we predicted a label of 0.5. That means my loss is 0.5, which is not very good, and you want to reduce that loss. And Atom does all the math in the background for you guys, so you don't have to worry about that. And then this is the core. This is training. It's really just one line. It's that simple. So we just do model.fit, and we give it a bunch of parameters. We give X, which is just the samples that we train on, Y, which is our labels. We reserve about 10% of it just for validation. Batch size of 10, which just means we pass in 10 samples at a time, and epochs 20, which means that we have more epochs. Let's say we change this to 30 epochs, we're going to see an increase in accuracy. So the more epochs you do, usually the more accuracy you get. But the reason you don't want to do so many epochs is it takes a lot of time and takes a lot of computing power. And here we see that from epoch 20, we saw that our accuracy was 93, and then we saw that it increased just a little bit. But at this point, our model was doing very well, so it didn't need to increase. Yeah. So again, the reason we're splitting off some of this is we want to make sure that our model is able to predict on data that's never seen before. And then from there, we see that we just predict based on this. And if we wanted to, let's say we wanted to just test one sample, we can just go ahead and do this, and we would just do, let's put another cell right here. So let's just, I say I want to just test one person's age and see what it would be. What I can do prediction is equal to new underscore model predict, and I just give it this. So, whoops, I have to print this. So when I print it, I see that it's a 68% chance that they will see a bad reaction to the drug. And then if I just do, if I round it, right? So if I do predict classes, and what this does is it just, it rounds up or down. And here we see that they will see a problem. So in the real world, if I was a doctor, I'll use my model. I'll tell my patient that, hey, you're 7 years old, and there's a 70% chance that you will see a harm from this drug. So be careful with this drug. Maybe we should find a new drug, things like that, right? And that's why you would use this in the real world. But I think that's again it. I think you guys should ask questions now, because not a lot of people ask questions in the Slack. So if you guys want to take some time to ask questions, that'd be great. Or about anything, about linear regression, about the model. Nobody has questions?
Is this code on GitHub?
Yeah, it's been on GitHub for a while. Is there any other questions? I hope you guys were able to follow. Again, it is pretty advanced. The problem is teaching machine learning to people who don't have a strong coding background is always going to be difficult. So it's always better to brush up your coding skills first, such as by taking the other Python class. And then if you took that, then you can get a better understanding of machine learning. And machine learning is really math-based. That's why for a lot of you who haven't taken high-level math courses, such as Algebra 2 or Pre-Calculus, will somewhat not be able to follow along. But if you get the basic idea of why you would use machine learning, how we basically give it an input, the model learns, that's all you really need to know at this point. If you learn that, you'll be fine.
So are there
Any
any
other question?
do you have any prereq links for the math?
I don't. I would just say that you won't, like, if you haven't taken Algebra 1, there's no way you'll be able to like learn all the math needed. And that's okay, because you don't really need to know the math to understand the concepts of machine learning, such as giving a data and learning off that data, right? You don't really have to understand the math to understand how the model works. And again, even if you don't understand the math and you still follow along on the code and you understand how to code it, you'll be fine. And later, once you also learn the math, once you get older and you go into high school and you learn the math, you'll be able to follow along a lot better, and you'll be able to learn a lot of the math and a lot of the background stuff.
So if you guys have struggled today at all, please make sure to brush up on any Python. I gave a few links in the beginning. Shivam has some links, so please check those out if you're struggling.
Yeah, and yeah. Any other questions now?
Yeah, what is the extension IPYNB? What does it stand for?
Yeah, okay, so PY means Python. I is just so IPython is just a language used for notebooks, and then NB is notebook, right? So it's IPY Python notebook, and the I is just to denote that it's a notebook.
Are we supposed to add what we coded today onto GitHub?
Yeah. If you were whatever you're able to code, you guys should add it to your repository so we can check over it and see how much you guys were able to do. And if you have any questions, if you guys want to do this on your own, obviously you guys should want to do this on your own. But if you guys want to really do it on your own, you guys can text us and just like message us on Slack, and we'll be able to help you.
I have a quick question.
Yeah.
So the last class that we did, where you guys explained all the math, wasn't posted on the tiny URL link.
Yeah. So I also looked. I didn't know why. I'll have to ask Shifam. He has a recording, so I'll tell him to post it.
Yeah. So because I couldn't understand this class as much because I needed to review that one.
Yeah. That like it was really big. It was really important to understand that stuff, and that's why we asked to go over you guys to go over the notebooks and have all the stuff downloaded before. But again, like as long as you understand the idea of like processing data, training data, such as like the epochs, you'll be fine. Any other questions?
Next class, we're planning to have you guys build your own neural network, like in a relatively advanced model. So hopefully you guys can understand what we did here today, and based on those lectures, the second and third weeks, please go over those before meeting here next week.
Yeah. Okay. So I guess last call for questions before we finish the class.
Can you review the concept of TensorFlow?
Sure. So, okay, I don't know where you're getting TensorFlow. We didn't really talk about TensorFlow at all. We talked about Keras. Keras is the machine learning library that is part of TensorFlow. And it's just a machine learning library that has all the functions you need. It has all the stuff you need to build models. It has all like the optimizers, the layers, everything you need.
Definitely don't worry about TensorFlow because Keras is what we're going to be using the entire time.
Keras is a part of TensorFlow, and Keras is specifically for neural networks and computer vision, which is images, or not images. No. It's just a machine learning library specifically for neural networks. But yeah, any other questions or? Okay, I think we're good for today. Thanks for coming out, guys. We'll send some links and stuff so you guys can get ready for next class. We'll probably send it by like tomorrow or in the next few days. So just check out the Slack and make sure you guys follow along. Again, I think a lot of you weren't able to keep up because you guys didn't download the code that we asked many times on Slack. So please stay updated on Slack to really know what's going on. But all right, bye.
Thank you.